Okay, we're in section 10.1, parametric equations and functions, and we're looking at problem 23, and the directions are find the points at which the tangent line, which of course, once we read tangent line, we should be thinking derivative, right? We should be thinking derivative. So find the point at which the tangent line to the curve is either horizontal or vertical. And it's important to remember that with a parametric curve, you could have any kind of action going on here. You could have, some sort of cycloid thing that's circling around, and maybe does it make a circle? Hey, an actual circle. Any number of different things. And so, the tangent line at any given point could look quite different. And so the tangent line, and we want to know, when is the tangent line horizontal, or when is the tangent line vertical? Okay, well, let's start with horizontal. If the tangent line is horizontal, for a tangent line to be horizontal, that's going to imply that the change in y is 0, right? Because if the line itself is horizontal, correct? If the line is horizontal, then the slope of that line is 0. So what we need is just dy dt to equal 0. And you might say, well, we know we need dy dx to equal 0, but with the formula, if we have dy dx equals this, if the top is 0, we're good to go. So we need dy dt to equal 0, so we find dy dt, and that is going to be just the cosine of t, because when we look up here, derivative of -1 is 0, derivative of that is cosine of t, and we need to set that equal to 0. So the question is, when does the cosine of t equal 0? And the cosine of t is going to equal 0 when t equals, of course, pi over 2, 3 pi over 2, and any multiplication of that. So it's any pi over 2 plus pi k. So then, but they want to know the points where this occurs. And so for the points where this occurs, that's an xy location. So for the points, I need an x and a y. So I need x of pi over 2 and y of pi over 2. So if I plug pi over 2 into my x function, I'm going to get 2 plus the cosine of pi over 2, which is, of course, 0. And then comma -1 plus the sine of pi over 2, which is 1. And so that's going to give me, my first point is going to be at 2, 0. But we also need to check, hey, what happens if we're at 3 pi over 2? So if instead I'm at x of 3 pi over 2 and y of 3 pi over 2, then I'm going to have x of 3 pi over 2. You're still going to have just 2 plus 0. And y of 3 pi over 2, you have -1, and then you're going to have -1. And so that's going to give you 2, -2. So these two answers match this answer right here. And then for part B, you're going to go ahead and you're going to do basically the same thing, but you're going to ask yourself, okay, well, what makes it so that I have a vertical tangent line? And of course, that's going to be a line that goes like this, and of course, that's going to imply that it has no slope, or an undefined slope is a better terminology for that. So it has that undefined slope, right, which is, number over 0. So the denominator equals 0. So that implies that we need dx dt to equal 0. And of course, dx dt is just going to be opposite sine of t. So we need to know, when is negative sine of t equal to 0? And of course, if negative sine of t equals 0, then sine of t just equals 0. So that occurs when t equals, so what what values give a sine of 0? So that's going to be 0, and then pi, and then, of course, it's just going to be pi k. Right? Any pi k. And so then now we need to check, when does that happen? So what is x of 0, y of 0, and then what is x of pi and y of pi? So x of 0 is going to be, we're looking back up here now, x of 0 is going to be 2 plus the cosine of 0, which is 1, comma, and then y of 0 is negative 1, and the sine of 0, which is 0. And that's going to get us 3, negative 1. And then x of pi would be 2 plus cosine of pi is negative 1. And y would be negative 1 plus 0. And so we get 1, negative 1. And those should match our answers up here. Negative 1, or 1, negative 1, and 3, negative 1. We got 1, negative 1, and 3, negative 1 are our two answers. And so that's how we would get it.